intermediates. There are 6 types of reaction intermediates, that is carbocation, carbanion, free radical, carbene, nitrene and benzene. Carbocations. A species having a carbon atom possessing sextet of electrons and a positive charge is called carbocation. Carbocations are the key intermediates in several reactions and particularly in nucleophilic substitution reactions. Structure. Generally, in the carbocations, the positively charged carbon atom is bonded to 3 other atoms and has no non-bonding electrons. It is sp2 hybridized with a planar structure and bond angles are of about 120 degree. There is a vacant unhybridized p orbital, which for example in the case of CH3 plus lies perpendicular to the plane of CH bond. Stability. There is an increase in carbocation stability with additional alkyl substitution. Thus, one finds that addition of HX to 3 typical olefins decreases in the order CH3 whole twice C double bond CH twice is greater than CH3 single bond CH double bond CH2 is greater than CH2 double bond CH2. This is due to the relative stabilities of the carbocations formed in the rate determining step, which in turn follows from the fact that the stability is increased by the electron releasing methyl group plus I, 3 such groups being more effective than 2 and 2 more effective than 1. You can observe from the given structures that tertiary carbonium ion is stabilized by 3 electron releasing groups. Stability of carbocation 3 degree is greater than 2 degree is greater than 1 degree is greater than CH3 plus. Carbanions. A species having a carbon atom possessing octet of electrons and a negative charge is called a carbanion. Structure. A carbanion possesses an unshared pair of electrons and thus represents a base. The best likely description is that the central carbon atom is sp3 hybridized, with the unshared pair occupying one apex of the tetrahedron. Carbanions would thus have pyramidal structure similar to those of amines. Generation. The first method of generation is from Grignard reagent. Consider the reaction CH3 CH2 single bond Br plus Mg gives rise CH3 CH2 single bond MgBr and carbon of CH2 group has considerable carbanion character. The second method of preparation is from triphenyl phosphine. Consider the reaction R2CHX plus PH3P gives rise PH3P plus single bond CHR2 plus X minus, which further in presence of base gives PH3P double bond CR R dash. Stability. More the electron releasing group on carbanionic center, less the stability. The stability of carbanion follows the order. The reactivity of primary greater than secondary greater than tertiary. Properties. Carbanions are nucleophilic and basic, and in this behavior these are similar to amines. Since the carbanion has a negative charge on its carbon, to make it a powerful base and a stronger nucleophile than an amine, consequently a carbanion is enough basic to remove a proton from ammonia. Free radicals. A free radical is a species which has one or more unpaired electrons. They are paramagnetic in nature. Free radicals are usually detected by electron spin resonance, which is also termed electron paramagnetic resonance. Structure and geometry. Simple alkyl radical have a planar trigonal structure. That is, these have sp2 bonding with the odd electron in a p orbital. The pyramidal structure is another possibility when the bonding may be sp3 and the odd electron is in an sp3 orbital. Unlike carbocations, the free radicals can be generated at bridge. This shows that pyramidal geometry for radicals is also possible and that free radicals need to be planar as shown in the given figure. Stability. As in case of carbocation, the stability of free radicals is tertiary is greater than secondary is greater than primary and is explained on the basis of hyperconjugation. The stabilizing effect in allylic radicals and benzyl radicals is due to vinyl and phenyl groups in terms of resonance structures. The resonating structures of methylbenzene is shown here. Carbenes. Carbenes are neutral intermediates having bivalent carbon, in which a carbon atom is covalently bonded to two other groups and has two valency electrons distributed between two non-bonding orbitals. When the two electrons have paired spin, the carbene is a singlet. If the spins of the electrons are parallel, it is a triplet. Structure. A singlet carbene is thought to possess a bent sp2 hybrid structure in which the paired electrons occupy the vacant sp2 orbital. A triplet carbene can be either bent sp2 hybrid with an electron in each unoccupied orbital or a linear sp hybrid with an electron in each to the unoccupied p orbital. The structures of singlet and triplet carbene are given here. Generation. Carbenes are obtained by thermal or photochemical decomposition of diazoalkanes. These can also be obtained by alpha elimination of a hydrogen halide from a haloform with base or of a halogen from a gem dihalide with a metal. CHCl3 plus OH minus gives CCl2, that is carbene plus H2O plus Cl minus. Nitrines. Structure. The nitrines Rn represent the nitrogen analogous of carbenes and may be generated in the singlet or triplet state. A nitrene can be generated via elimination or by the thermal decomposition of azides that Rn double bond N plus double bond N minus gives rise to Rn plus N2. One of the methods of preparation of nitrene is given here. Reactions. In their chemical behavior, nitrines are similar to carbenes. Nitrines get inserted into some bonds, example a CH bond to give an amide. Aziridines are formed when nitrines add to C double bond C bonds. Benzene. It is a reactive intermediate in some nucleophilic aromatic substitutions. It is a benzene with two hydrogen atoms removed. It is usually drawn with a highly strained triple bond in the 6-membered rings. Benzene intermediate has been observed spectroscopically and trapped. One of the reactions of formation of benzene is given here.